Hello everyone, my name is Abhishek and welcome back to my channel. AI Cloud Cost Detective. Yes, we are going to build an AI Cloud Cost Detective in today's video. Just imagine this. You have an AI utility, you build that on your own, it connects to your cloud platform, looks at the resources on the cloud, looks at the configuration of the resources, and instantly tells you how you can modify those resources to bring your cloud cost significantly down. A lot of times you misconfigure the resources or you over provision the resources. But this utility can tell you what changes you can make and bring down the cloud cost. Wouldn't that be awesome? Now you might say, but Abhishek, there are some open source projects like Carpenter. Yes, these projects are good, but they are restricted to certain cloud services. For example, Carpenter works well with Kubernetes clusters. But with the help of AI, what we are going to build today is something that works with most of the cloud services. And it works with your virtual machines, it works with your S3 buckets, Kubernetes clusters, databases, volumes, anything. Most importantly, you are building this on your own. Let's say there is an open source project tomorrow, but still, because you made it on your own, tomorrow if there is a requirement within your organization, you just provide a prompt, modify the tool accordingly, and it is ready in minutes, right? By the end of this video, I will make sure you have everything that is needed. And after watching the video, you can go back and build this by your own. Just like any other project on the channel, I've created a GitHub repository for this as well. The GitHub repository has architecture diagram, it has the request flow, and most importantly, the prompts that we are going to use in building the project. We will do this in 5 simple steps, right? Just to make sure everyone understands the project clearly. I'll break down this into 5 steps. First step, problem statement. I'll explain you what is the requirement, why are we building this project, what problem are we solving. Second, I'll explain the tooling that we are going to use. What tools are we going to use to build this project? We are mostly going to use open source tools. Then I'll walk you through the architecture diagram, a detailed architecture diagram so that you understand how each component is connected to other. Fourth, I'll walk you through the request flow so that you understand how a user's request flows within the platform. Finally, implementation. Then I'll head to my AI coding tool. I'll start building this application. You can use your GitHub Copilot, you can use Claude Code, you can use Cursor, anything that you have access to. End of the video, as I told you, you will be building the project. Perfect. Now, without any delay, let's get started. Let's start with the problem statement. Abhishek, why are we building this AI Cloud Cost Detective? Is it really important? Very valid question. Let me explain. Majority of the organizations today, it can be startups, it can be mid-scale companies, large-scale organizations. They are deploying their workloads on the cloud platforms today. From containers to virtual machines to S3 buckets, databases, volumes, everything is on cloud today. Cloud is definitely good. There are so many advantages of cloud. Cloud is very reliable, it's durable, and most importantly, cloud resources can reduce the management for you. But on the downside, there is also a downside. If the cloud resources are not provisioned well, it can significantly cost your organization. Unfortunately, this is what is happening with majority of the organizations today. They expect their cloud billing to be, let's say, 20,000 US dollars by the end of the month. But what they see is 50,000 US dollars. Why is this happening? Maybe the junior DevOps engineer has misconfigured the cloud resources, maybe did not follow the best cost optimization practices, or maybe the junior DevOps engineer has over provisioned the cloud resources, provisioned more than required. End of the day, it will cost a lot for your organization. Abhishek, what organizations do today? They can't do much. They just pay to the cloud platform, whatever the cloud platform is charging them. They pay to the cloud platform. And as an afterthought, maybe end of the quarter, end of the year, they just go to the DevOps team. They ask the DevOps team to prepare a report, which is usually called Cloud Visibility Report. And in the report, they want to see which team is responsible for how much cloud cost in the organization. And maybe as a future project, they will introduce cloud cost optimization. This is what happens in majority of the companies today. Now, is it good? Kind of good, because at least they are taking afterthought measurements. They are getting the report, and in future, they have steps to optimize the cloud cost. So it's kind of good. But what we will build today is an AI tool that will not act as an afterthought, but it can prevent organizations from huge cloud costing. Instead of waiting till the end of the month and paying that 50,000 US dollars, using this AI tool that we are going to build, organizations can reduce that to maybe 30,000 US dollars, or maybe even 20,000 US dollars as per their expectation. Sounds good, right? Abhishek, how is this going to work? I'll just give you some very high level information now, because we anyways are going to talk about architecture in step 3. But how this works, the AI tool that we're going to build, it connects to the cloud platform. In today's video, we will use Azure Cloud. A lot of you are asking for Azure, so I decided to go with Azure Cloud in the video. But it doesn't matter if you want to use the same project for GCP or AWS, it works as is. Only in the prompts that you're using, change Azure to AWS or GCP. You don't have to change anything else. So your AI platform connects to the cloud platform. It looks at the resources, all the resources within a resource group. It gets the configuration of the resources. Because it is AI, large language models, it gets the information of the best practices. So it compares your existing configuration with the best practices configuration. And then it provides you a detailed summary. Like for S3 buckets, this is a change that you can make. For virtual machines, this is the change that you can make. In fact, it can also provide you some commands if you need. So this will act as a prevention mechanism. And this is how it is going to work. We will make it enterprise grade. We will add authentication to it. We will add storage to it. We will add a very good database to it, so that you can also see the investigation history. Perfect. So I hope at this step, problem statement is clear. So the problem is that companies are paying a lot to the cloud today because of misconfiguration or over provisioning the resources. Our AI cloud cost detective can prevent this by connecting to the cloud, by fetching the resources, by fetching the configuration, and comparing the configuration with the best configuration from the Azure documentation or from other resources on the cloud. It can also suggest the changes that the DevOps engineers need to make. Cool. Now, before going to the architecture, let me quickly talk about the tool set. I know a lot of you are interested in this because you want to understand, can I actually build this project or not? You can build it. For front end, we are going to build a full stack application, an agent application that has front end, back end, database, everything using AI. For front end, we will use React. React is user friendly. Users can get to the platform. They can use it in a very easy way if we build it using React. Then for the backend or for the programming language, we will use Fast API. Fast API is basically Python. So using Fast API, we will fetch the resources from Azure. Then for the database, we will go with Postgres database. Postgres is very popular open source database, and it also comes for very less pricing. So we will go with Postgres in the video. In one of our previous projects, we used InSforge. If you want, you can try InSforge as well. That is also good. Then for the authentication, we want this platform to be enterprise ready. So we want to implement authentication as well. Even for authentication, we will go with Postgres. So we will store user information in Postgres. And then we need model gateway. What is model gateway? We have to send, like, backend collects the information of Azure resources. We have to send that Azure resources to, let's say, to large language models. So we will be using OpenAI in this case. Don't worry. If you are confused at this point, wait for the architecture. Once we head to the architecture, everything will be clear. That's it. These are the tools that we are going to use. Of course, for cloud, I'm using Azure. And for fetching the Azure resources, that is for the data, I'm going to use Azure CLI. Abhishek, why not go with Azure APIs? You can go with Azure APIs as well. But the problem with the APIs is that APIs keep changing. You have to make sure you are using the right version. You are using uh, the right input to the APIs because it keeps changing. Down the line, your maintenance with the application that you are building will also be more. We want to keep the maintenance low. So that's why I'll go with Azure CLI. So this is the tool set that we are going to use in the video. Now let's get to the interesting part, architecture. Abhishek, explain the detailed architecture of the project that we are going to build. Why not? Let's talk about it. Firstly, users. Who are the users? It can be developers, DevOps engineers, or your management. Anyone who wants to use this platform, they will just head to the user interface of the platform, or we can say they will head to the front end of the platform. Within the front end, the first thing that they see, they will not see connection to Azure, but they will first see the authentication. We don't want everyone to use the platform. We want to restrict who can use the platform. Maybe a junior developer should not use it, or maybe a junior tester should not use it. Someone in the operations team, maybe they should not use it. So we will restrict the authentication to it. Once the authentication is successful, let's say the authentication is successful, then user would see an option to provide the Azure resource group. So either they can select the Azure resource group from the user interface, or they will provide the ID of the Azure resource group. Now, once this is provided, this is the key part. This is where our backend comes into picture. That is, our Python comes into picture. What our backend does, backend connects to the Azure CLI. It will make use of Azure CLI, and making the use of Azure CLI, it will fetch the resources from the cloud. What all resources are available in the Azure resource group. And once the information is fetched, it has to fetch a lot of information. So we will use multiple Azure CLI commands here. Good part about the CLI commands, over the period of time, they don't change. If you look at Azure CLI command for fetching virtual machines today and maybe 3 years before, the command is almost the same because CLI always maintains the compatibility. 99%. I cannot say 100%. Okay, once this resources is fetched, because this is huge information, this is sent to AI. This is where we are going to use OpenAI API key. If you want to reduce the cost, you can also go with Open Router API key. But I already have OpenAI API key, so I'll go with it. It doesn't matter. If you have Anthropic API key, go with it. If you have Open Router API key, go with it. What AI does, it performs the analysis, right? The critical part of our entire architecture. AI performs the analysis. AI looks at all the cloud resources. It looks at the best configuration for those cloud resources. And once the analysis is done, it provides us with a summary. Like it tells the user, hey, these are the steps that you could have done better. You have configured Kubernetes cluster with 6 nodes. Probably you only need 3 nodes. You have created virtual machines with a particular instance type. You don't need that instance type. Probably you can go with a lesser instance type. And along with the summary, it can also provide the steps. And this is shown to the user back on the front end or on the user interface. Again, the same path. Information is stored within the database. This analysis is stored within the database where we are using the Postgres database. And from the database, backend fetches the information and shows it back to the user. This is what happens end to end in the application agent that we are going to build, or the agent application that we are going to build. Let me quickly explain this one more time. This is the important part. Please try to understand. First, users talk to the front end. Front end, users cannot connect to the cluster or to their Azure cloud platform. There is an authentication in place. We are using Postgres for this authentication. If the user is authenticated, user can provide the resource group. This resource group, name of the resource group is taken by the backend, where we are using Python or Fast API. Backend makes use of Azure CLI. It connects to the Azure cloud platform and it will fetch information from the Azure cloud platform. This information is sent to AI, where I'm using OpenAI API key, but if you want, you can go with Open Router API key as well. Then this information is sent to analysis. This entire analysis is summarized and shown back to the user. But to keep the history of the information, to keep the history of the investigation, maybe I ran this investigation on 29th of May. Someone else also want to see it instead of running it again. If the platform provides investigation history, they can just go to the history board, or they can just go to the previous investigation and see what has happened. So they don't have to run this entire thing again. And yeah, you can find the same information in our GitHub repository as well. If you head to the README file, you will find architecture section where you can find the same thing that I explained on the whiteboard, probably little more detailed. Along with that, you can also find request flow section. Abhishek, why do I have to write this in the README file? There is an advantage. See, when we are planning to build an application using AI assistants, it can be Cursor, it can be GitHub Copilot, Claude Code, or even OpenClaw with local models. I mean, using Olama. When you provide architecture diagram and when you provide request flow, there are chances it can build your application in the very first run. When you provide prompts, of course, I'll walk you through the prompts. We are going to provide very detailed prompts as well, but still there is a chance that your AI coding assistant might get your requirement wrong. But when you put the information in this way, in the architecture diagram, in the request flow, there are very less chances that it can go wrong. That's why I've documented this information in the GitHub repository. Perfect. So now we understood the problem statement. We understood the tool stack, the tech stack that we are going to use. We are clear with the architecture diagram. We are also clear with the request flow. So what's next? The next step is implementation. But before we implement, there are two prerequisites in this case. One, you need an Azure account. In my case, I've created an account and I've created two resource groups here. Let me increase the font. So you can see this is my Azure account. I've created two accounts here. I mean, two resource groups here. The payments request, payments resource group, where I have bunch of resources in here. For example, in the payments resource group, I have a Nginx virtual machine. Then I have networking related to the Nginx virtual machine. I have some premium disk. I have orphan data disk. Along with that, I also have a storage account. Similarly, even in other resource group, I have created bunch of resources. If you look at the middleware resource group, I've created storage account here as well. I've created a bunch of virtual machines, the networking of the virtual machine, and I've created some orphan disks, basically some disks that are not used by the virtual machines. So our Azure account is ready. You can also set up something like this. You can ask, let's say you're using AWS, you can ask ChatGPT to give you some AWS CLI commands and create some infrastructure on AWS. Or if you have expertise, go ahead, create some resources, create some Kubernetes clusters, make your cloud platform ready. Because end of the day, we want to play with the cloud environment. AI Cloud Cost Detective, it works better when you have more resources on the cloud. Only then it gets the opportunity to look at the resource configuration, see what you have configured wrong, and then it can detect and give you the suggestions. Perfect. So our Azure cloud environment in my case is ready. Now the second thing, we need OpenAI API key. Even I have that thing ready as well. I use OpenAI API key, so I have it ready. All that you have to do, like let's say you want to use OpenAI API key, you have to get to platform.openai.com. Then you have to get to the API keys. Click here, create a new secret API key, provide a name. I'll say, let's say, let me call it detective. Choose the default project or you can create a project. Then click on create secret key. Once you have this key, copy it and paste this key within the .env file of the project. Basically, you can clone this GitHub repository. Within this GitHub repository, you can create a .env file and paste your OpenAI key there. Perfect. I'll create a dummy.env file here so that you understand where exactly to copy the OpenAI API key. Abhishek, I don't have OpenAI API key. It's okay. You can go with Anthropic API key or OpenRouter API key, which is much cheaper. In the previous project, I used OpenRouter API key. That's why this time I'm using OpenAI API key. That's it. There is no other specific criteria. Cool. So both our prerequisites are also ready. Now let's head to cursor. Cool. So I have a cursor subscription, so I'll be using it. I'll go to the agent section and I will start with the first prompt here. I've cloned the repository. I've created .env file. As I told you, this has my OpenAI secret. I'll start with the very first prompt. Go to the GitHub repository. Can you guess what will be the first prompt? The first prompt is to create the Python backend, right? What is the core piece of our entire architecture? If you look at this entire architecture, the core piece is the Python backend. So Python backend will take the resource group as input. Then it will make use of Azure CLI. It will fetch the resources from the Azure cloud. So if you get this piece working, right? If you can get this piece working, then rest of the things are little easier. Okay. Let me show you how I wrote this prompt. So first of all, I explained create a Python fast API backend in backend folder. So I'm asking it to create a folder in the Cloud Cost Detective project. Okay, that's fine. A fast API server with post/analyze input endpoint that accepts resource group. So this is what I told you. The Python backend should basically accept resource group as input. User will provide this information from the front end. Then I said get/API resource group endpoint that returns list of other resource groups. Okay, this is fine. Then use the Python subprocess module to run Azure CLI commands. You understood why I wrote this here in the prompt? Because we want to use Azure CLI. If you don't put these lines here, from here to here, if you don't put these lines in the prompt, by default, your AI coding assistant, that is cursor, would go with Azure APIs. And Azure APIs can constantly change. Maybe 2 months down the line, somebody will report that your project is not working. CLI is more compatible. Then the basic things like enable cores, include requirements.txt, and this has to be the structure of it. This is the line that plays the critical role. Abhishek, why did you add architecture.md and requestflow.md? I just explained. Even in the prompt, I'm explaining within the prompt, refer to architecture.md and requestflow.md. This is why I added these MD files. Imagine if I don't provide this, and if I provide this entire prompt, there is 10 to 20% chance that it might create the Python backend for you, but not as per your requirement. When you provide this, then your chances of efficiency will increase by 10 to 15%. Cool. Okay. So I'll take the raw mode. I'll copy this entire prompt and paste it on the cursor. I'm using Opus 4.6 high. If you want, you can switch the model. Composer 2.5 is also good enough. It will consume less amount of tokens. Let me switch to that. Okay. Now I'll provide this prompt and wait for 2 to 3 minutes because this is going to take time. It has to install Python, then it has to download the required dependencies. It has to find Azure CLI on my machine. So let's wait for 2 to 3 minutes here. Nice. So this is done. In fact, it took less than 2 minutes. It created the backend where it created main.py, Azure scanner.py. It also created cost detector.py. Let me quickly walk you through these files. Main.py, the primary entry point. Then you have the cost detector.py. This is the actual file, I mean the core file. So what it does, it lists out the resources and things that are cloud cost detector is looking at or detecting. What are the things that it is detecting? One, oversized virtual machines. So it is trying to see if there are any Azure virtual machines on your cloud platform that are oversized or over provisioned. Maybe requirement is only 2 CPU, but it is created with 5 CPU. Orphan disks, disks that are not connected to the virtual machines. Stale hot blobs. Blobs are, I mean, if you are aware of Azure, blobs are like S3. Geo redundant storage. Redundant storage accounts. Unused static public IPs. Wow, this is something that even I did not expect. Probably if I'm writing something like this, I wouldn't have thought of unused static public IPs. This is a good one. Why? Because a lot of times you create public IPs, especially if you're working on enterprise, and sometimes you delete the virtual machine or you move to Kubernetes, you forget about that public IP that you have created. Of course, it does not charge a lot, but still in AWS, Azure and GCP, elastic IPs or the static IPs, they are charged. So even the one that we're building is looking at any stale or unused static public IPs. Load balancers without backend, good. Permissive NSGs, oversized OSDs, same thing, like just like oversized virtual machines, oversized disks. Unused file shares, like file shares are like EFS on AWS. Abhishek, what if I want to add more? Okay, these are 10 good things, but I want something like app services. No worries. The logic is here. What you have to do, just create a new line. Oh, it also, I mean, the AI also picked up app services. Very surprising. But anyways, like if you want to add app services, just add the flag here, then follow the implementation. For example, you can just follow this particular implementation, detect permissive NSGs, see how is this function written or definition written. You can add the same thing for app services as well. Abhishek, I'm not good at Python. Then don't add this flag. Instead, just head to cursor and add a prompt here. Enhance the agent application to also detect stale app services, right? Or issues with the app services. Similarly, if you want to add storage accounts or anything more, you can go ahead and do it. It's that simple. And this is the flexibility I was talking about. If you go with an open source project, if you're looking for a feature, they might not have it. And if you want them to add the feature, you have to create a support ticket, you have to wait for them. But in this case, you can add any feature in matter of minutes. And the complete control is with you. Good. Okay. Then in the Azure scanner, I think you might guess it. What is this doing? This is the file that is connecting to your Azure console using Azure CLI, and it is getting the resources. Basically, this is getting the resources on the Azure cloud platform, and the cost detector is trying to detect some information. But end of the day, okay, this is the complete Python backend, but end of the day, without AI, analysis is incomplete. Now let's add the analysis part. How do we add the analysis part? Go back to the repo. In the repo, just go back to the prompts folder. You will find OpenAI analysis. Go to that. OpenAI API integration for cost analysis. Build on top of existing fast API backend. By the time you're running prompt 2, the prompt 1 has created the fast API backend. So that's why build on top of existing fast API backend, add AI powered cost analysis using Open API directly. Create AI analyzer.py module. Take the list of Azure resources that we get from Azure scanner.py. As I explained you here, Azure scanner.py gets the resources within the resource group. Now AI will scan those resources. Build the prompt asking AI to analyze the resources for over provisioning. Yeah, the same thing. Whatever we have in the detection file, detect.py. Call the OpenAPI chat, OpenAI chat. We are asking it to use the GPT-4o model. If you want, you can go with GPT 5.5 or any other model. In fact, you can ask it to use the different models, so OSS GPT model as well, depending upon the tokens that you want to consume. Then the basic information. Again, even if you look at the prompt 2, end of the prompt 2, I've provided the same thing. Refer to architecture.md and request flow.md. If you look at any file, you will find, any prompt, you will look at this line at the end. That's the reason why the efficiency is more in my case. In the very first prompt, cursor was able to generate the backend as per my expectation because of this line. The same thing will happen with prompt 2 as well. Okay, now let's go back to cursor. Either we can create a new agent or we can continue with the existing one. Anything works. Okay, I'll close these agents. I'll click on a new agent and here I'll say just paste the prompt. Now this is also going to take another 2 to 3 minutes. This time it has to just collect my or understand where is my OpenAI key, the API key. Then it has to frame the prompt. Once it is ready, I'll walk you through the Python file as well. This is also done. So I can see AI analyzer.py is created for us. This is getting the information, the resource group information. It is creating a system prompt and it's sending the resources to the GPT-4o model as expected because we provided GPT-4o in the prompt. If you want to change here. So till now, what did we implement? We created the fast API backend. So fast API backend takes the resource group name. It detects the resources using detect cost flags, the 10 flags that I shown you. It sends the information to the OpenAI models for analysis. This is what we implemented till now. What are the missing pieces? Let's go back to our architecture. So here we implemented these things, the backend, we implemented OpenAI analysis. Before we head to the front end, before we head to the end-to-end integration, one piece that's left, the Postgres implementation. Postgres in this case is performing very interesting things for us. First, see, we don't want users to run this platform very often. Like, let's say we hosted this AI Cloud Cost Detective. 5 o'clock, someone provided a resource group and they got the information. Then 5:15, if other person runs for the same resource group, what's the point? Nothing is going to change in 15 minutes or nothing is going to change in 1 hour of time. But this will only waste AI tokens for your organization or AI is going to charge your organization. So what we will do instead of this, we will maintain the database which stores investigation history or it will store the past detections. So at 5:15, if someone wants to run, they can just go to the history, see if someone executed it today for a specific resource group. If they have executed the detection for the specific resource group today, they can just view at the history. Along with that, whenever user runs the cloud cost detective, they should see the real-time progress, right? For example, this is taking 2 minutes of time. You should show something on the screen that it is currently detecting virtual machines, currently detecting stale blobs, currently detecting the static IPs. So user has to see some progress on the dashboard, on the user interface. And finally, authentication. Authentication as well as authorization. This is also important. Right now, we will only implement authentication. All these three things will be done by Postgres. So this is the prompt for Postgres. If you go to prompt 3, Azure Postgres WebSocket.md. Let's see what is in it. Build on top of existing fast API backend, the same thing, whatever we have till now. Add Azure managed Postgres for storing user analyzing history and fast API WebSocket for live progress updates. Same thing I just explained. But we are using Azure managed Postgres service. What is the database to use? I mean, I'm providing little more information. Go for Azure managed Postgres, connect to this. Then I'm asking it to store the DB connection string in .env, where I'm already storing OpenAI API key. Then I'm asking it to create two tables. I'm providing the table information. Abhishek, in the last project, we did not provide table information. We did not provide database schema. Why are we doing it in this project? So if you remember, in the last project, we used InsForge. InsForge is basically AI native backend, but Postgres is not designed as an AI native backend. So we have to provide more information here. That is what I'm doing here. And also I'm explaining in terms of real-time progress. I'm telling AI, I should see something like this. When user runs my cloud cost detective, they should see what is the current status. For example, fetching resource group, scanning resources, analyzing cost, storing results. If it is going to take 2 minutes, user is engaged in the meanwhile. And user knows that my agent application is not stuck. Just provided an example of .env.example and finally refer to architecture.md and request flow.md. Let's go to the raw mode. I'll copy this entire thing and I will paste it here. Okay. Now let me just put that information here. As expected, it took little more time, but you can see prompt 3 implementation is also complete. It created a db.py file, progress.py and auth.py file, individual Python files. In the db.py, you can see there is a table. This is the analysis table. This is the users table. And the logic to connect to the database, the Postgres database. The Postgres connection string is as part of the .env.example file or the .env file. Okay, so this part is also complete. So we have our Postgres database also set up. So all this information is complete. Now we are only left with front-end implementation and front-end connection with the backend. So two different prompts. In the first prompt, we will create front-end. Let's see if we like the front-end, we will use it. In the first go, if it does not develop the front-end well, if you're going with AI agents like Lovable or other solutions, you can be rest assured front-end will look good. But because we are going with cursor, I doubt. In the first go, if the front-end is good, we'll use it. Or otherwise, we will modify the front-end. And in the next prompt, we will establish the connection between front-end and back-end. That will complete our agent application. Let's do that. So we will go to prompt 4. So prompt 4 is to create React frontend. Okay. Create the React frontend in the frontend folder, just like the backend folder, and make use of JWT. As we discussed, right? Authentication will be implemented using Postgres, and that will be using Java Web Tokens. And here we are saying setup using White. White is the server for running frontend, React, and TypeScript. For CSS, we are asking it to use the Tailwind. Authentication, specifically using custom Java Web Tokens. I provided little information on how to use the authentication. For encryption, I mean the endpoints for authentication like sign up page, login page. And for encryption, I'm asking it to use bcrypt. And these are the different pages on the front end, like the login page, dashboard page, analysis report, and the history. Whatever we discussed. These are the 4 pages on the front end. If you want, you can modify it. Like if you feel like, Abhishek, I want everything in one single page. I don't like the multi pages. Then you can change it, like put everything under one page. It's up to you. And finally, refer to the architecture.md. Cool. Let me copy this and paste it in the cursor. Front end will not take a lot of time. Probably in 2 minutes, we should have the front end developed for this application. Let's see. Once it is done, we will track the progress. So the front end is also complete. You can see JWT is also set up. I mean, authentication is also complete. But I doubt it will work at this point because although we created the front end for AWT to work, I mean JWT to work, the Java Web Tokens and authentication, it needs a connection with the Postgres database. So we still have to implement front end integration with backend. So my bad, it might not work. I mean, front end is created, I'm sure, but front end will not be able to connect to the database at this moment. So let's also go ahead and run our prompt file. Integrate front end and back end. We cannot review front end at this point. So let's complete this. Integrate front end and back end, basically end to end. What are we saying here? Connect React front end with fast API backend, wire a WebSocket for live progress, authentication for all the routes, and display the history. More information here, like the API integration information, WebSocket, history information, and I'm also asking it to perform a final test so that we don't have to go see something is wrong. Instead, it can perform the final test and say if everything is looking good. Cool. So let me run this. And once this is complete, then instead of just reviewing the front end, let's review the end-to-end application. Cool. And again, this is a very simple thing because for front end and back end integration, it just has to use an existing SDK. And with the SDK, it will wire up the things. Postgres database is already available. Looks like it is done. I can also see on the terminal. So there are two terminals. I can see the Wheat server is running. I hope it is done. Let's see. So we'll go back to the same thing. I'll provide again the same email address. Let me provide the password for it. Okay, now we have the front end. Front end looks very minimalistic. Here is the email address, logout option, dashboard. It also has the history. And on the dashboard, it provides a toggle button where I can, or drop down where I can see different resource groups. Same thing on my Azure cloud. Right now, I just have 3 resource groups. Let's select one of the resource group. We will go with the payments resource group and see. I'll quickly run the analysis. Okay, WebSocket connection failed. Ensure that the backend is running on port 8000. Is the backend running? Oh, no. Okay. So we can clearly see here, we'll resume when background work finishes. Looks like there is some issue with backend. Even here, I can see the error. We'll just paste this error. We don't have to debug this. I'll paste it here or the error that I have here on run analysis. Let's see if AI is going to fix this for me. I hope it should be a straightforward issue. It fixed the issue for us. It says the API is now running at 8000. Let's see. One more time we will test it. I'll refresh. I'll select the resource group again. Payments Aqua, run analysis. Perfect. So it started running the analysis. Analysis is in progress. Fetching the resource groups, scanning the resources, analyzing the cost with AI, storing the results, and analysis is complete. So these are the things at the moment. Okay, it took like 10-15 seconds, but I can see this is the analysis report. It shared the resource group. Resources scanned are 10. Issues found are 6. Estimated monthly savings is 200 to 500 US dollars. See, this is a big thing. I just created 10 resources on my Azure cloud. It scanned the 10 resources. It figured out there are 6 issues. It provided a summary as well. The payments Aqua resource group has several high severity cost issues, including oversized VMs, orphan disks, and multiple things. Here is the summary of each issue, and you can see there is a command and there is estimated saving as well. So here, this is the first one, oversized virtual machine, which is on payments Nginx virtual machine. It is saying right now we are using standard D4 AS V7. Payments Nginx virtual machine runs on, okay, this one with 4 vCPUs, but appears suited to a lightweight workload, Nginx Simple API and web proxy. So just for Nginx and Simple API, we created 4 CPUs. It is saying you don't need it. You can just go with standard B2S. Let's see if it is true. So I'll go to my Azure Cloud Platform. Let me put this here. Okay. Let's see what it is saying is true. I'll go to Payments Aqua resource group. I will go to the virtual machine that is talking about Payments Nginx VM. Payments Nginx VM. Okay, this is the one. What is the configuration of it? So its current configuration is D4 AS V7, exactly what it mentioned. And it says we are underutilizing the resources. Let's see. I'll go to monitor. What is the CPU utilization? Oh, yes. So you can see the CPU utilization is very, very less. Percentage of CPU that is used. And even the memory utilization is very less. So that's why it recommended us to move to standard B2S. I think this comes with 1 CPU. Perfect. Very good option. Very good cloud detection, the cost detection. Then it says orphan disk, even with payments orphaned disk 2, you are going with premium LRS, but it says you can just go with data disk 2. You don't have to go with the premium tariff. And here you can save 20 to 50 US dollars. Let's see again if it is true. Payments orphaned disk 2. I'll go back. In the same resource group, I should see payments orphaned disk 2. Okay, this is the one. And it is using the tier. Let's look at the tier. Premium SSD LRS. What it mentioned is true. It is of size 256 GB, but our utilization is almost 0. So it is saying you don't need this premium LRS. Very good. Again, a good suggestion. Similarly, it talks about unused static public IP addresses. It says you have this static public IP address, payments unused PIP. You can just remove it. Okay. And this will save $5 per month. Overlay permissive NSG, and it also provided this is high severity, this is medium severity. Additional resources, it also provided some additional resources that we can go through. So our analysis report and our AI Cloud Cost Detective is working as expected. And I'm happy with the user interface as well. I thought cursor will be generating something which does not look good. It happened to us last time, but this time it generated pretty well. And I'm happy with it. Now let's see one overall, like end to end, because we tested this functionality in multiple levels and we gave it multiple prompts. Now that our agent application is ready, let's view it in one end to end go. I will sign out of this application. And now let's see end to end flow. So on my Azure Cloud Platform, I have 2 resource groups. And in each resource group, I created multiple resources, which would cost me around 50,000 rupees. But most of these resources are misconfigured. I mean, these resources are configured in cost inoptimized way. Most of these resources are over provisioned. Let's see, we build this AI Cloud Cost Detective. If it will detect the over provisioned resources and it will help us in saving the money. So I just signed in. This is the Cloud Cost Detective dashboard. It already looked at different resource groups I have. It figured out. I'll select one resource group, click on run analysis. It is fetching the resource group information. It is scanning the resources. It is analyzing the cost with AI. It is storing the results in the Postgres database. And finally, the analysis is complete. It will provide us with the detailed report. This is the analysis report. So it says we have 10 resources in the resource group. It found 6 issues and it can save 200 to 500 US dollars just if we follow the steps that it provided. First of all, it identified the virtual machine is over provisioned. It says run this command so that you can switch to standard B2S. Then it says there is an orphan disk, delete the disk. It says there is another orphan disk, go ahead and delete it. It says there is one static public IP address that is unused. Also delete the static public IP. It also provides information about over-provisioned NSG and oversized OS disk. It also has the information where if I click on the history, these are the previous analysis reports. If someone wants, they can go here and look at the previous analysis. Cool. So this is our AI Cloud Cost Detective. I hope you liked it. You can build this for AWS, Azure, GCP. Everything remains the same, architecture and request flow as well. So go through the GitHub repository, go through the prompts that I have provided. Just modify it accordingly for AWS or GCP. If you like this video, please share it. If you have any questions, do let me know in the comment section. Even if you find it good, let me know in the comment section. See you all in the next video. Take care.